Hello, how are you? I'm Mom Judy Olarman. Today, I will discuss about ionic bond. This lesson explains how an ionic bond forms. What is ionic bond? When we say bond, it is a force of attraction that holds the two atoms together. Ionic basically consists of metal and non-metal. In this lesson, we need to recall where you can find metals and non-metals. Look at this periodic table.
So let us review the periodic table. Elements located at the left side of the zigzag line except hydrogen are considered as metals. On the right side are called non-metals. The zigzag line represents the metalloids or semi-metals. At the middle, in this part, these are metals with different charges to explain further as we go on. Here's the definition of ionic bond. Bonds that are formed by transfer of electrons from one element to another. Ionic bond formed by losing and gaining of electrons. This bond involves cation and anion. By the way, what is cation? When we say cation, it is a positive ion. Anion is a negative ion. Which element form cation? How about an ion? Normally, metals form cation and non-metals form an ion. Look at this table. The charges of each group are stated. The valence electron represents the group number. The charges indicate the type of ion that can be formed. Ion meaning the number of protons is not equal to the number of electrons. Group 1, 2, and 3 form a positive ion. They normally give or donate their valence electron. The name is as it is, plus the word ion. Example, magnesium, positive 2, is called magnesium ion. Lithium, positive 1, is also known as lithium ion. All group 1 have one valence electron and tend to form a positive 1 since they come with one valence electron. All group 2 form positive 2 and positive 3 for group 3. For group 4, either positive 4 or negative 4, and that is another topic to be discussed when we move to the next type of bond. The non-metals normally gain electrons, forming negatively charged an ion, which have charges that are the group number -8. Example, group 7 nonmetals form -1. All group 7 form -1. For group 6, form -2. And for group 5, form -3 charges. In naming the non-metal ions, just add a suffix IDE. Like for example, chloride for chlorine, oxide for oxygen, nitride for nitrogen. The transition metals can form more than one possible charge in ionic compound. They are using their oxidation number, so they are not included to the given rule. So an ionic bond, basically, it forms from the main group 1, 2, 3, and 5, 6, 7. Here is the formation of the sodium ion. Sodium is atomic number 11. Here is the electron configuration. 1s2, 2s2, 2p6, 3s1. 2 plus 2 plus 6 plus 1, the total of 11. 3 is the valence shell, and this is the valence electron. There is only one valence electron. When we say valence electron, it is the number of electrons that is located in the valence shell, or the highest energy level that is responsible for the chemical reaction. In sodium atom, there are 11 protons and 11 electrons. Positive 11 plus negative 11, the net charge is 0. In the formation of sodium ion, when its valence electron transfer to the other atom, the electron configuration turn to 1s2, 2s2, and 2p6. It is isoelectronic with neon. Isoelectronic means having the same number of electrons or the same electronic structure. So there are 11 protons and 10 electrons in sodium ion. Positive 11 plus negative 10, the net charge is positive 1. That is how net charge produce. As I have said earlier, the tendency of group 1, 2, and 3 usually transfer their valence electron to become stable. Here is the formation of chloride or chlorine ion. Chlorine is atomic number 17. Here is the electron configuration. 1s2, 2s2, 2p6, 3s2, and 3p5. The valence shell is 3. There are 2 plus 5, the total of 7 valence electrons. There are 17 protons and 17 electrons. Positive 17 plus negative 17, the net charge is 0. The chloride form when the element gains an electron. Since there are 7 valence electrons, the chlorine needs only 1 electron to become stable. The general tendency of group 5, 6, and 7 usually accept electron. Then, the electron configuration turn to 1s2, 2s2, 2p6, 3s2, and 3p6. It is isoelectron with argon atom. There are 17 protons and 18 electrons. Positive 17 plus negative 18 is equal to negative 1. The net charge is negative 1. That is how chloride form. Nonmetals such as group 5, 6, and 7 usually accept electrons. The question is, why the atom needs to transfer or accept electrons? It is because of this concept. the octet rule. In forming compounds, atoms tend to gain or lose electron in order to achieve the electron configuration of a noble gas. The atoms of noble gases already have complete outer shells, so they have no tendency to lose, gain, or share electrons. That is why the noble gases are inert and do not take part in chemical reactions, so they are unreactive. The same explanation to the atoms presented. An atom is considered stable by having 8 valence electrons in its valence shell. How does ionic bonding take place? A sodium atom donates a valence electron to chlorine atom to form a sodium ion. So the sodium ion becomes stable by having 8 valence electrons. To satisfy the octet rule, as you can see in the illustration, there are 2, 4, 6, 8 valence electrons. The chlorine atom takes an electron from sodium atom. When it does, the outer valence shell of the chlorine will be filled with 8 valence electrons, and it will be stable. There are 2, 4, 6, 8 valence electrons. The loss or gain of valence electrons allows ions to obey the octet rule and become more stable. Why atoms need to become stable? As you can see in the illustration, at the right side, they need to become stable for the formation of a useful compound, sodium chloride, which is also known as salt. That's all for today. Thank you for watching.